All right, you made it to the third day. Everything been good so far? So far, so good. More coffee, more caffeine. Got 2 espresso machines here in Seattle, so we're going to keep those going all day long. Glad to have everybody here. I know I've met several people in the hallways that I've known or met and visited at their campus, so happy to welcome you to mine as well. You made it to the third day. Hopefully the content has been great. We've got some more coming through for the rest of today, and hopefully everything's worthwhile. I want to get us kicked off today, and I'm going to start talking a little bit about some industry trends. And after that, we'll go into talking a little bit about what we're doing at Microsoft around some of those trends, some stuff on client, some things on cloud. And then I want to walk back into something very germane to this topic, which is our application lifecycle management, our development tools. How do those things relate? How are they going to help you work on exactly those topics? So if I look at some of the top-level trends, and these are by no means meant to be exhaustive. There are certainly lots of things happening in our industry right now. But if I had to pick 5 to go talk about, these are 5 that kind of bubble up to the top to me. The first thing is we're basically moving into tons of devices. Many of us, I'm sure, are traveling. Well, if you're like me, I just got back from South Africa. I had 2 laptops. I had a tablet. I also had a phone, everything else associated with me. Your friends are on that side of the room. There you go. They're waving frantically over here. But I've got lots of devices in my bag. I think you guys are probably doing the same thing. Now, the one thing we're all getting kind of used to is these devices are enabled for touch. We're getting very, very common on those sorts of things, right? You're reaching and doing that. I've got my Lenovo ThinkPad laptop that I'm doing my presentation on here. It also has a bunch of fingerprint smudges here on the screen because I'm used to my phone. The only problem with that, this isn't a touch laptop. I don't know if you guys have had that problem before. I'm actually running Windows 8 on this particular machine, and I've gotten pretty used to using Windows 8 on my developer preview machine from Build. And I've got that plus my phone and everything else. You're kind of, you're used to it at this point. And here we are with touch being very common. So I think you're going to see that. I'll talk a little bit about kind of Windows 8, some of the content we talked about at Build coming up in a minute. The next thing is I do expect that applications at this point, people expect them to be connected. We have to support offline. Don't confuse those two. Obviously, we're going to keep doing that. I think email is my favorite. I'm constantly connected with my phone. I'm getting my email updates. Of course, when I take long plane trips especially, I like to have my Outlook backed up on my machine and running locally. So I want to have support for both of those. But increasingly, when you get a device, it's connected. It's got some kind of connection to some kind of wireless network, or take your pick. And I think consumers are starting to expect that. That kind of brings us into consumerization of IT. And this is a kind of a big trend, especially with the proliferation of devices. And IT departments trying to get a handle on that. What should I do with that? Do I lock it down and you only get to buy from this list and I'm going to kill bit every device that I have? Or am I actually going to allow and have a more permissive, kind of usage of employee devices coming in? Those are decisions that CIOs are making right now and trying to figure out. I'm sure you're probably thinking about the same thing. But there's another angle on this for a developer that comes in, which is as more and more people get regular devices and they buy them from a consumer perspective, and they're buying applications off of the store, and they're getting used to using those devices, those interfaces, and that sort of thing, they're starting to become much more used to those sorts of metaphors. And I'm seeing increasing demands for, hey, why isn't our internal software, why does it look like it was written in the 80s? Right? There's a lot more desire of how do you make this thing touch-enabled? How can you make it more intuitive? Right? I can just pick up a device and buy an app, and I know how to go use it. Yet when I use internal software, it's kind of hard to navigate. So we start to think about how can we kind of make those two trends work, especially if you're going to be bringing in these devices, get those things connected, and get really great user interfaces, which ties back into the nice touch thing. Social is also becoming very interesting across many things. I mean, Facebook is one thing, Twitter, and you can't watch a commercial without having both of those embedded, and most commercial websites are going to have it. We all kind of know the story there. But within the enterprise, you're starting to see a lot more demand for social, just for networking. And if you get back into the developer space, I think you're starting to see more and more of the engineers that we're going to hire coming out of university. And they've grown up on all of this. And in fact, if you ask a lot of them when they come out of university and school and what have they learned, oftentimes I find that they'll just kind of skip over some of the reference material. If I got a question, I'll go up to my social network and wherever that coding network is and just go ask my friends, and they will help tell me. And I'll use that as kind of a reference point to understand how should I get things done, how do things work. So this connectedness, not only do we see it in the regular corporate environment, but I'm starting to see it come in as part of the development and engineering experience as well. Sometimes these days, I don't know if you do this, people will actually ask for your online code account so they can go code review and go see what commitments you've made. And that's part of the interview process with many startups these days. Go give me your GitHub account. Go give me your online account. I want to actually go look at the code you wrote, which is kind of interesting. It's kind of a new angle, but it's something else we're starting to see kind of proliferate through. Finally, cloud and services is very, very clear. We are definitely moving into a world where everybody is evaluating cloud and trying to understand what that looks like. I'm going to talk about both of those coming up. Let me start off, I guess, right away with cloud itself and give you a little bit of background on what we're doing. I think Scott Guthrie was here earlier this week, and Mark Rusanovich is going to be coming through as well. So you should get a good picture of what we're doing. Let me give you the top-level overview. The primary thing we are trying to do with our strategy, we do see a world in which you're going to wind up with lots of what we call continuous services. And it basically says that as we move more and more to the cloud, the way in which we structure our code also starts to change. We had a client-server era where we wound up with larger servers and larger clients, and they kind of split the workload, and these things were often very tightly connected. Whereas if I go into continuous services, I might be using more loosely coupled services to compose my architecture. Those things will actually take advantage of each other, but they'll be smaller, less kind of monolithic. That gives me a certain amount of agility and introduces a new set of problems that we have to go after. But nonetheless, it gives me the capabilities of taking advantage of cloud scale, the economics around that, et cetera. And so I'm finding that a lot of enterprises especially, most are kind of going in, they've done physical to virtual, they got that, they did that many years ago. Many are now trying to figure out how can I get a private cloud story, especially around things like data security and trying to figure out what that means, and they're making some progress on that. And then they do have interest in a public cloud, and they're trying to figure out how do I balance those two, and we're trying to enable that. The second thing is this devices concept that we talked about, right? I think we're getting to the point where you have numbers of devices that are going to show up. We hope to have some of the most popular versions of those devices, but recognize from a cloud perspective, they're not going to be the only ones out there on the network. And we need to make sure that we're building tools and software, especially on our cloud, that will allow you to actually create software that's going to work across whatever you need to go support. So connected devices is definitely there. And in this world, your PC just becomes another one of these connected devices, just like your phone. If you want to have slate categories, however you taxonomize these machines, even my kid's Xbox 360 account, the Xbox Live account, it's another device. Netflix streaming to your player in your living room. All these things are connected. You got to have infrastructure that can support all of that. So what are we doing about that? If you look at server and tools business, which is the kind of P&L that we're in, we're the T and STV, the tools piece, and the server piece, as you can imagine, Windows Server, SQL Server, Azure, SQL Azure, all the rest of those sort of System Center, all of our kind of enterprise and back-end components. So our picture is actually pretty thorough. We have a public cloud. If you start off at the top, you can see a public cloud that we allow devices to connect to. That's Azure. And we have worldwide. I'll show you the data centers in just a minute. But that's basically our plan on public cloud. And it does a great job supporting programming models like .NET. And we will, of course, continue to provide choice and flexibility there. I think Scott probably talked about that. Mark will probably talk a little more about that. But this is the environment that we try and create for the public cloud, so you can take advantage of that. But we also recognize that that's great, but not every workload is ready to move into that mode. Right? I mentioned before, security. You may be evaluating security of your data and access. You may have rules and regulations that you have to take care of. So we also, of course, care a lot about having your kind of on-premise solution. And with a combination of Hyper-V and the new work we've done with Windows Server, the latest version of Windows Server 8, you can get that combination and build a really fantastic private cloud. More self-service, more kind of auto, replication, a lot less, personnel required to run these things. And it really does get you prepared. And because we're using the same programming models and tools, we want to make it so that those of us here, kind of more in the engineering area, that we can actually write workloads that can take advantage of both of these environments. So you get a little bit of symmetry there. And again, I can connect devices. Now, the final thing that's interesting here is that, okay, that's great, but I may have workloads that, frankly, I've been maintaining, building, and driving for 20 years. That's not that uncommon at all, especially for a very established company. Now, we've got cases where, for example, airline has on-premise and all of their data is there. They're not ready to go rewrite that and go rehost everything up in a public cloud. But you do want to have this devices presence, the piece at the top. Notice that all these pieces are connected. Okay, we call it hybrid IT. And what that basically amounts to is I can keep my on-premise workload, and I can keep running that where it is and keep the data local from where that is as well. But I can actually go up and put a public cloud endpoint supporting like a REST API, for example. I can take that small piece of code and put it up in a place like Azure, support public APIs, and now get device connectivity. And we've invested a lot in identity and security to help you make that connection between those two. And so, for example, with Azure, the ACS, the Azure, connectivity system through identity, I can actually go back and make a secure and robust connection from the public cloud to my on-premise workload and just get the data that I want. So, for example, if I were a ticketing reservation system for an airline, I could actually have my mobile application for remote check-in or mobile check-in on my phone. And I could just make a call with my user, my confirmation number, have that go up through the cloud, tunnel back down on-prem, and just get the check-in information back up and out. Now I can have this kind of connectivity. So I get to keep my existing workload, but I get to have a cloud presence associated with it. And when I'm ready, if I'm ready, on my time frame, I could move that to private cloud, and I could move that to public cloud as well by the time the thing gets going. So we're really trying to provide that full, very comprehensive story. So it's not just a great big black or white, well, everything's on-prem, or go rewrite all your stuff and go shove it up in the cloud and you're good. I think it's going to take all of us, especially in the enterprise kind of space, it's going to take us a while to kind of sort out what makes sense, and we're going to have to take advantage of that. It is worth it. You're going to get the cost savings and things like that, but nonetheless, you can make it an intentional part of your roadmap. So with Windows Azure Platform, I think I covered the basics here, but how do you enable that? Well, you can kind of think of Azure itself as being an OS for the cloud. So all of the subsystems that you'd want to program against are things that we're going to put inside of Azure. So storage, the support for viewing a service bus for messaging and things like that. Compute, having database, so blob storage, database storage, et cetera. Security that we mentioned. All these things are required in order for you to be able to write a workload against that. And they're all of the things required for the building blocks. As you can see, what we've done is we've also, like I mentioned, done a really good job incorporating .NET as well as some other programming environments. And we tried to design the API set in such a way that when you write your applications, if you find some missing APIs that you're like, hey, I'm used to calling this API, it's gone for a reason, and there's an alternative, and that's mostly to help the code scale. Great example of this, we changed around some of the IP sniffing APIs, because what would happen is sometimes people would write code that on startup would go grab the IP of the machine that it's on and go use that in some kind of an index data structure. Well, if we need to go silently move that, fail that code over, pulled up multiple instances, that's not very portable code. So we're actually giving you different APIs that help you write the code so that as your engineers implement this stuff, it actually has a chance of being able to scale out. Just one good example of that. Data centers for the public cloud, we basically are locating these worldwide and continue to improve and add additional capacity to all of these. So you're pretty much covered in regions, Europe, the United States, as well as Asia, and we'll continue to make investments there. So at a top level, those are the high-level changes that we're making. And of course, we're going to make sure that all of the tooling that we're doing helps you build really compelling workloads for that cloud, including all of the ALM work, that we're talking about this week. Let's talk a little bit about the clients. That's kind of the back end side of the house. Let's talk a little bit about the client side of the house. A couple different things we're working on here. First of all, I will mention right off the bat that our back-end piece, before we go into phone, our back-end piece is designed to help you get connectivity. We are helping you write rich applications for the Microsoft stacks, but what you will see, and I'm sure Scott showed you, is the ability to take things like ASP.NET, run it in the public cloud, and we've made a lot of investments in MVC4, for example, that will allow it to detect devices, do a better job of flowing data. And so, for example, if you are supporting an iPhone or an iOS kind of app, then we want the web server components to actually be smart about how it does the layout, how it fetches the data, so you can actually write that sort of application. Now, if I go into our devices, then I can see, well, we're doing a significant amount of work on the phone. Windows Phone has been out for a while. The Mango release is there, and hopefully you've seen all the new kind of devices that are coming out in the news with our Nokia relationship. And I think there's some fantastic devices that you're going to see that come out of that. So there's a few things with the version. What we're trying to do is really make sure that we have great integration with the browser. You will see this consistently across our client stacks. We're investing heavily in HTML. I'll talk a little bit about the presentation stuff up in just a minute because I know it's a very common question. But we really do believe first-class HTML with reach support is something we do need to have, and we're going to do a first-class job on it. In addition to that, we've tried to make the devices themselves very smart. You see the tiles that are on there. You saw something similar with Windows 8 as a prototype. So not having to actually go in and activate applications is actually really nice. I came over here this morning. I just basically pulled up my home screen, and my Outlook calendar is a nice big wide bar with this hour blocked off with this room. I didn't have to go activate any kind of a calendar app. I just found it on my homepage. It's pretty easy and straightforward. I've got the weather notifications this morning out of the Weather Channel application. Evidently, we're getting snow tomorrow, so you picked a good day to finish up at the conference. People don't drive incredibly well when we get here, so we'll get you out of here sooner. But nonetheless, you get the idea. It's the notification systems, everything else. It's a nice kind of interface to be able to get that. And we're also trying to make sure we do a good job with connecting and sharing. One of my favorite features with the Windows Phone Mango is I've actually can do one post that will actually update my Twitter account, my Facebook account, and my Live account. Type it in once and go. And then on the other end, there's one home screen, just the me. When I go in there, I can actually go to one place and see the aggregated feed of everything coming back. So again, rather than trying to fumble through it, I can actually see all of it. So these are places where the underlying operating system itself is helping you with multiple apps and domains, so that we can actually pull, aggregate, and give you that nicer experience right through the system. So better sharing, better searching, better integration across the apps. It just makes the device and the apps get stronger and better. So that's kind of what we're doing and trying to line up there and create really compelling and great looking apps. And again, with touch, fully connected, with social, all those industry trends that we mentioned from before. Now, I briefly showed on my laptop here Windows 8. How many people have downloaded Windows 8 out of curiosity? Excellent. That's fantastic. I see probably about 45% or so. That's awesome. And so hopefully you saw that September we had the Build conference, Build Windows conference, where we unveiled the developer preview version. This is a screen snapshot of that. This is the start page. You'll see some of the similarities that I just talked about with phone. Again, here I have the tiles with data. My weather app is right there. The kind of news and headlines, the top level ones are right there. I can click through it. Again, optimized for touch. If you haven't seen it, watch the keynote, which is great, but there's a session right after the big picture session by Jensen Harris, which is really awesome, and it goes through the UX of why did we make these changes? Why did we decide to build this kind of interface? And what makes a really great modern application, right? And it includes things like actually reducing the amount of Chrome. Like you'll notice that you don't see a lot of start bars, you don't see a lot of stuff around the outside. You're seeing content. And when the apps come up, the content goes pixel to pixel from corner to corner, right? So you get to maximize that. And things are made for your finger as well. It turns out my fat fingers are not really great pointing devices unless the software helps me out, right? There's other sorts of problems too, like what's a hover effect for your finger? Think about that. On hover. I mean, how many websites do you hit where you drag the mouse over something and a new menu pops up? How do you do that with your finger? It's like, do we get events like, 5 millimeters, 4 millimeters? It's like, no, it's not a proximity thing, right? So you have to kind of reimagine the way that you build things so that touch is actually enabled as a first-class thing, that it's going to work, that as a user I can, kind of get through it, manipulate it easily, and understand it. And so that's a lot of the theme that we've put in here. And again, if you watch the videos, you'll also see things that like the search is a great example. One place to search. And with one place to search, I can actually get results across all the domains of the apps that are registered locally, rather than having to say, well, I'd like to go do a search here, activate app search, or activate another app search. No, I just swipe search, here's a term, and boom, I get everything out of that. So fantastic, kind of new stuff in there. And again, what you'll see from a programming perspective, we've made a significant amount of support in the system. The system itself is going to support, and does, XAML for markup, C# and Visual Basic, as well as C++. So if you're using XAML, you're familiar with that markup, you can use any of those three languages to go write an application like you see. In addition to that, we are supporting HTML and JavaScript. Very simply, I'd like to get every developer I can to be able to write for this application environment, because I think it's going to be compelling. And if you look at the run rate of something like Windows 7, 450 million versions of Windows 7 and counting, you should expect to see that, I think, in the future with the Windows 8. And I'm going to get that, really great kind of support. Well, we want all of those developers to be able to come in. So we're building tools for that. This is actually a new version of Expression Blend. This version it works with HTML. and we have, of course, the version that works with XAML as well. We're investing in both of those. In this case, you'll see a ton of markup, and we do find that some people do actually like to write their code very much directly in the angle brackets. So we give you a great editor experience. We let people go do that. This same code right here is actually this application. And so for other people, this is probably a little bit easier to see, right? But you can see, again, first-class design support for HTML. Now I can get the nice kind of tiles and layouts using the controls, get all my colors, and so I can actually pull in a professional developer, or designer, excuse me, if they want to come in. If you want to make it look really, really cool, you can go do that. I also feel like for internal applications, I talked before about the notion that we got more and more people in our workforce getting used to these interfaces. I'd also like to make sure that the tools I'm giving you allow you to build pretty cool applications right out of the box just with Visual Studio and with Blend, so that you don't have to go hire a professional. If you're doing externally facing, like maybe you're a bank and you want to write an application that your folks in the branches are actually going to use with an actual customer, you probably do want to go hire a professional and get them to really make it look great. But I sure love for you to be able to just use some of the templates out of the box and write some really great looking software that's touch enabled, uses the controls properly. So it's some of the core design principles that we're trying to do, make building an app like this actually not that hard. And so you don't have to necessarily hire a pro designer, but you can do that. We're going to make sure that both work. If you haven't seen it yet, there's tons of information up on dev.windows.com, including about, a good couple hundred hours worth of material and deep dives explaining, the top-level principles, the goals for the system, what the programming environments look like, examples of writing applications from scratch using Visual Studio. I've got a new version of Visual Studio Express coming out, which gives you support for building Windows 8 Metro-style applications, so the Metro applications. And, of course, will be included in the regular version of Visual Studio 2. So the version that you get eventually, you'll have that capability. And actually, all MSDN subscribers and Windows 8, as you saw, about 45% of us have got it already. And I'm running it, and you're good to go. Last thing I'll mention on this is you also saw when I briefly switched focus over here, I'll do it again just so you can see it. When I go off and go do the start, I do have the Windows Start page here and all the applications that are installed. One of those, just to make sure, because I get a lot of questions about this, is the desktop. And as you can see here, I am simply just running, I can just launch Visual Studio, for example. That's the developer preview of Visual Studio 11. But I'm also running PowerPoint and everything else. So all your existing applications, and that includes all your Silverlight WPF applications, Windows Forms applications, anything else you may have been building are going to continue to run in the system. So you can kind of get into this new touch-enabled Metro-style API system, but you don't have to simply go off and rewrite all your apps for it. You're going to have the advantage of using both, which is pretty awesome. All right, so that's a little bit about some of our client and our cloud and our backend pieces. Let's wrap it back around, and let's talk a little bit about some engineering trends and come back in more on topic around ALM itself and what we're doing. So given all these trends we just saw, okay, what do we do about that, and how are our jobs changing? I want to talk a little bit about agile practices. I think we're definitely at a point where we've hit great saturation with agile practices. I like to say agile practices because there is no one methodology per se. There's just tons of ways in which people implement it, and we haven't coalesced 100% on any one thing. I think what you are seeing, or at least I'm seeing, is a tremendous use of Scrum. But every time I talk to somebody and we look through it, we kind of compare notes, and we're all kind of a slight vector off of what each other is doing, but the basic components are there, which I think is actually fine. We ourselves, when I finished up the Visual Studio 2010 and before we started the Visual Studio 11 cycle, I actually put the entire engineering team, about 1,000 people, through Scrum training. Because not everybody had used it. Some teams were actually using it a lot, especially our ALM teams. They were already using Scrum through the 2010 cycle, had great results. And so we've gone back and actually put everybody through Scrum training, and we probably have about 85% of the engineering team now using Scrum for this release cycle. And I've actually seen some pretty fantastic wins out of using that. Now, we use a combination of sort of things, and I'll actually talk a little bit more about that coming up. I'll use a combination of waterfall at the top level, as well as using Scrum on the feature team level. I've got some more slides. We'll talk in detail about that. But I'm definitely seeing that, and we are investing heavily in that. The next thing is testing advances, because if you're going to make your system run very well, and you're going to actually increase your your release delivery cadence, reduce cycle time, more releases quicker with higher quality, we got to get a lot better about how we make changes, how we build it, how we get it out there. We got to really do a great job on that. DevOps, also a big part of this. You're going to see a theme here. Developer operations, getting to the point where, hey, it's not really done until my customers can actually load it up and use it. And we have a lot of traditional experience with building software where we run into issues along the way. So what are we doing about that? And then finally, developer services. So as we start thinking about the cloud, how does that impact us from a developer perspective? So I'm going to hit all of these topics in our next section, and then we'll go into kind of Q&A. So first I want to provide a little bit of context. And some of you, I think you probably have seen this. I think it's good for level setting and just letting you know where are we coming from. So even if you've seen this before, I'm going to hit it again just so that we're all on the same page. In particular, this is my team. We are globally distributed. I've got folks on the left coast, right coast, Midwest of the United States, with a huge percentage of us here in the Redmond area. We've also got an engineering office in Zurich. Eric Gamma's running that team. And then we've got a team in Hyderabad in India, as well as Shanghai in China. And I wouldn't be surprised if this is very, very similar to many of you, most of you in the room, where you have lots of offices and you're trying to do kind of coordination across all of them. So we have a lot of shared problems here. Quality assurance, is the code of right quality? Am I ready to release? The distribution problem of just getting the messaging and collaboration systems to work. How is the project doing? If I'm managing a portfolio of projects in particular, are they landing on time? Am I going to meet or miss my deadlines? The collaboration efficiency that comes out of that, and then getting that value out to customers. I mean, that can be difficult to do across this environment. Now, context, again, why did we build the system we did? Well, we went back and had a conversation with folks, and this would have been, back in 2003, 2000, whatever, and we really sat down and said, what's the number one reason why software projects fail? And there could be many reasons for that. The tools aren't quite good enough, the technology's got some bugs associated with it, I don't know, the trends keep changing, I got crazy bosses asking, there's all sorts of stuff that it could be. But the number one answer that came back was collaboration, lack of collaboration. Every time I do a handoff from one to the next, something else could go wrong, right? I can get gaps between these things. And the longer the handoffs are, the more stuff goes wrong. And then the harder it is to get the software out on time. So if you look at that, well, I mean, back in the 90s, we did dev-to-dev collaboration. That's source control, and everybody's been doing that for a very long time. And that was actually great, right? I mean, it's a good innovation. You've got to be able to share source code in a sane way across large teams. Okay, good start, but not really the be-all, end-all. If you go and look through Lean, now we start saying, well, hold on a second. I need a little bit better rail on this thing, so we're all working together. And we know that software just doesn't come from devs typing in code. Right? I've got to have architects that are doing design. I've got requirements, in our case program management, but requirements going in, the design of the system that's got to be in there, writing the code, testing the code, deploying the code, all these sorts of things need to be there. And so we had to go back and say, well, how do we pull these groups together? And that's why we came back to create something like TFS, because it gives us one core system where we can actually get that integration across the board. So there's collaboration through integration, and one core part of our strategy. Another core part of it is something we call actionable feedback, which basically means if I've got two roles that need to collaborate, the software better be helping me with that. Okay? I'll give you a few examples of that. So if you look at our roadmap, we started off with 2005 and 2008, and that was really this transparent foundation. So get TFS in there. Get it so the devs and everything else can be talking to each other, especially for developer and collaboration. This is where we get things like, hey, when I do a check-in, I want the change to be tracked with the work items that it went with, and I should be able to start getting much more clarity and transparency on that. And then, by the way, I'd like to start seeing from a top-down point of view, as an engineering manager, how is that stuff going? With 2010, we added another couple of roles. We added architecture, and we added more testing support. Architecture, this is things you've seen where we talk about how do I avoid drift. There's what I want as an architect, and there's what somebody checked in. And those aren't always the same. And that's painfully annoying. So we tried to create tools that would both allow you to reverse engineer what you've already got. That's the kind of discovery components. Then go in and do things like layering diagrams. So this is what I really want. And then enforcement. So that as you get these two things to come back together, I can actually enforce it going forward. Now I don't get the drift. Same thing with the testing, right? So being able to go through and do automated testing, coded UI, all of these things are required. Now I can start getting that kind of collaboration. So adding those roles makes it more complete for the team. Now, if we look at a little bit of context for our own team itself, I mentioned we've got tens of millions of lines of code. Some of the oldest code that we build and produce and ship is probably the C++ compiler, which is easily 20-some years old at this point, which is probably not too different, from some of the code bases you have. And some of these systems are very, very large. Individual components could be 2 or 3 million lines of code by itself, like most of the .NET framework as an example. And so getting that through the system and across all these teams is a challenge. A few things that we wind up doing. One, we started going back and saying, well, how do we go through and do scenario-focused engineering? I mentioned before that I put everybody through Scrum training. When we started the Visual Studio 11 project that we're currently doing, I also put everybody through SFE, scenario-focused engineering, right? Which was basically like, hey, look at it from a customer standpoint. I'm a dev. I spent a lot of years. I was one of the original devs in the CLR. So I did a lot of engine room sort of stuff. And it was really fun to create algorithms, and I loved it. But we kind of got a little bit of this problem sometimes where it's like, I got a cool algorithm. Look what I can do with it. It's like, okay, but for whom? Like, what's the point? And what I was finding is there was a disconnect between the engineering team's ability to translate why they were doing something to the customer that actually needed something. And so the scenario focus has actually helped us significantly. That plus Scrum was a really great, set of changes for us, because now we can actually come in up front and say, what scenarios are you trying to enable? Why? And Agile kind of helps with some of this, some of this templatizing by user stories. As a, I want to, that sort of thing. That's a scenario focus, because it helps you get clarity on why are you doing this thing, and now you can push some more decision making down into the system. Similar kind of deal here. We got to break this whole thing down and get down to the lower levels. As an example, let's take the Windows stuff that I showed from before. A scenario here might be, I'd like to be able to go build a XAML C# Metro style application. Okay, that's a scenario. That's pretty high. Now I have to break it down. Well, I need to be able to do file new project, so I need some kind of template that can actually compile. I'd like to be able to have an editor that's enabled for this, a designer, a debugger. Now you start breaking things out all the way down until I get down to, hey, when I set a breakpoint on this and it's up on the second screen, it's full screen, or on a connected device over here through Ethernet, I better be able to hit a breakpoint here, tilt it for accelerometer, and get it, see this over here. Now you're getting down into these experiences and features that have to get implemented. As you can imagine, with the kind of stuff that we have, these databases get quite large, and there's a significant amount of planning associated with that. And of course, the big thing is it's all got to come together so I can ship it to you on a regular cadence, so that no matter which of these interfaces you're using or whatever language you're using, you kind of expect the debugger to work. It better, right? So that's kind of how we break it down. After that, you get into, how would I actually go build out and do my requirement sort of pieces? This is another part of this. And this is actually one of Sam's original markups, I believe, from like 2004. Goes quite a ways back, but imagining the original TFS project itself, how the heck would I do this in walkthroughs? And we think the flow would work like this. Do you like this? Maybe some of you have participated in some of our SDRs or customer feedback councils where we don't actually have product yet, but we're walking you through, here's what we're kind of thinking. Do you like it? Right? It's the same requirements gathering that you guys do and get feedback on. This is one of the original ones actually 5 or 6 years ago. After that, we start getting into feature implementation. And some of these things, some of these you're going to see here are actually hand-coded charts and queries that we were running off of our original 2005, 2008 product cycle, where the data was stored in TFS, but we were actually doing custom data pulls to figure out, well, which charts and things would you like to see, right? And a lot of the stuff that we drove was around what interest do we have? Because as an engineering manager myself, you can imagine asking 1,000 people, what's your status today? They're really excited about giving me that. I'll drop everything I'm doing to tell you that right now. It's like, no, we want the product to do that for you. So just doing a check-in gives me data that I need. We're both happy, right? So here's measuring feature progress and how, what the kind of lockdown looks like and that sort of stuff. Here we get down to the feature team level, so we can actually track in which teams are doing well and which teams are having issues. Gives a good view. Here's an even broader one, but this is at the business level. So this might be a featured team crew right here. Like this one's got annotation on here, folder diff, so it's kind of a source controlled TFS kind of feature. This might be the entire TFS team and how they're coming in on time and are the schedules headed in the right direction. Once I get back out, how do you get that much code to work together? You need a pretty good branching system. And so this actually, all of our code that we ship we got a similar structure for Visual Studio 11. Our code name was Dev 10 for Visual Studio 2010. With this version, Basically, we have main. That's where all of our code ships from. But then we go back, and these green things, they're probably product units, maybe 100 people. So what you might see on the left-hand side, you can actually see the names. NDP, that's the .NET framework. So on the left side of your screen, you'll see NDP has got a couple of branches there. So .NET and the CLR, so you might have 100 people working on the CLR. Underneath of that, what you don't want is the garbage collector guys checking in daily, or the JIT guys. Think about that. When's the last time you worried about whether an if statement went the right way on the branch? You don't do that, do you? If you're in that branch, sometimes you do, right? Because you got code gen guys, and they're going in, they're changing stuff, right? I mean, so it's, sometimes you're going to get a compilation error. So we kind of don't want, branch prediction issues, branching issues to show up all over the tree, or it's chaos. So it's got to be kind of separated. So this is a way to go do that. So the branching features and stuff that you see are designed to go do that. You see the Pro team over here, VSTS, the original name for team system, the ALM efforts. So you get a big bunch of these. And then we do branching integrates where everybody has to go up on a regular basis, and everybody's got to go down on a regular basis. And we used to have these integration periods that we have where the longest one that I did on integration was .NET Framework 1.1 and Visual Studio 2003, I think it was, where at the time we did not have everything in the same tree. This is actually a better system. I'm telling you, why did we get here? I'll tell you why. We had separate source control systems. This was back in 2000. Separate source control systems for the front-end compiler, the CLR, the IDE, and some of the other compilers as well. And so this process, what it kind of looked like is I'd go into the CLR, because I owned that team. I'd make an instruction change. Because remember, we were still new. We were adding things like, say, generic support or things like that. I'm actually changing the type system and putting new instructions in there. All right, so now I can compile from C++ up so I get a machine that can actually work. But remember, I don't have any BCL yet. Right? There's no system.string just yet, because I don't have C#. Okay, what do? I go copy those DLLs over to the C# team. Hey guys, here's a new runtime, the bottom half. They go off, go make the changes, retarget the instructions. Now we recompile C#. I can now compile. That's awesome. Pull all of that back over, recompile the BCL, because you can't compile the rest of the framework without that, and then go take all that and copy it over into the framework tree. Now we can compile like WCF and all the rest of that sort of stuff. And 3 weeks later, there's a build that actually works together. That's how long it took. It's like, guys, there's got to be a better way, right? So the structure you're seeing here is not by accident, and the investments we made in TFS were also not by accident. It was to go solve exactly those sorts of things. How do you get that down? So in this world, we're actually all in one tree. One build system based on MS Build, TFS backing everything. The database itself here was about 17 terabytes by the time we were done, because we've got lots and lots and lots of code and lots of builds and everything else. But everything that we built up to this point was designed for exactly that kind of big problem, because we kind of figured if we can scale to tens of millions of lines of code, thousands of people working off of one great big tree system, then we should be able to handle most of the big workloads in the world that are doing that same kind of work. And so that's basically some of the background on it. Now, looking forward, and I'll speed up through these. Value props, so getting progress and reporting. You're going to see the theme in here is mostly, as items go through the system, how are we doing? Is it red, yellow, green? Good kind of top-level indicators for project health and trajectory. After that, we get into things like performance measurements. This is actually our performance, kind of scorecards that we use here for weighting and being able to get that. In fact, that's another thing I'd like to bring more into the system. We have some performance tools with profiling and things like that. There's even more that I could do from internal tools that I've got for automation, regression checking, and those sorts of things. So we'll bring more of those through, but this is a good example of how we go back and check by team. All the teams are in there. This is a bit of an eye chart. But we actually track this on a very regular basis. What you'll see in this grid, and I don't expect you to read it, the grid itself you can think of is columns are teams. Okay, so if I, third from the left is the CLR. That is basically, the core of the .NET framework. If I keep going off to the right, then I'm going to go find our SharePoint work on the Office dev piece. I've got the C++ product. I've got the VB product, the C# product. All of those are in there as columns. ASP.NET, blah, 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 blah. And then there's all of the capabilities we have to have, exit criteria. Like before we're done, this has to go bright green, right? So all the way down the side, you'll see things like, have you localized it? Is it world ready? Is it going to work in every country and every locale? Do I have versioning figured out? Is the licensing stuff working? Have I done all my security checks and scans? Is everything in there and ready to go? Bang, 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 right? So we've got to get the entire thing. So tracking this level of the software has to be done on a regular basis. And I got to be able to know if a team's hitting issues that we got to go fix, and do they need help? So this kind of data coming back up is super helpful. After that, we get into the sign-off criteria. So this is the same view, only with trajectory, and it's more on the overall health and status of the product itself, so more at the portfolio level rather than the business teams. And then finally, we drive a bunch of stuff through scorecards based on that same pool of data. There's actually, I've got my team, I have a team that actually helps with this. They send out a report like this weekly. The columns in here, we took out the names so you don't know who's only 49. Was the worst team off? C++. No, I don't know. I don't know who exactly it was. But we took their names out so we didn't have to say that. I'm just teasing one of my friends that runs that team. But overall, you see all the goals in here. The interesting thing here is, what are the columns? The columns actually have more to do with the point of the cycle that we're in. So if you're up at the front of a product cycle, then we're tracking things like, are your requirements done? Are the specs in place? Do you have your MQ engineering work? Are you ready to go? Right? And as you get further in, you'll see this one: automation pass rates, bugs per person, perf broken tests, perf to goal, dog food usage, all these sorts of things. Dog food usage. We always say dog food. It's an American thing. Since Eric has joined our team, he's like, no, it's drink your own champagne. Don't eat your own dog food. So we're going to probably change this to champagning or something like that. But we're going to get the right sort of content on here. If you look across these guys, this is really driving towards the end of the milestone. Right? Because I've got the code. Right now I'm trying to drive quality into the code. So I want to know that your automation passes are going well. Everyone is using the product, because we will absolutely use the product before any customer does. I need to get my entire division on top building. We're happy with it. It looks good before we ever give you a drop of source code. You shouldn't be my testing for that. I want feedback, but I should be doing a great job. So this is the end of the cycle. But it helps us get the data pushed through and we get the right thing. All of this content that you see here, again, some of the stuff coming up from a combination of 2008 and the 2010 product line, we wanted to turn around and make this something, because we figured, hey, if we're pulling all these reports and getting this data back, it's probably something you would like to have too. And so in 2010, we pulled the same thing back, and then we put it into the suite. You should be very familiar with this here. And I also called out Team Explorer Everywhere. That's our support for especially Java, Eclipse plugin, Mac and Linux, because we recognize that teams are heterogeneous. They've got more than just one kind of technology that they're using. We still like to have one team working together, so we can combine those things in there. So what do we wind up doing? And hopefully you're using some of this stuff already, but I wanted to show you where it came from and why we built it. In this case, the burn down dashboards, how am I doing? Am I making a track on everything I'm supposed to be implementing? Are we doing good at estimating the time? Because that's going to give me long term, am I on track or not? From a quality perspective, test plans, test cases, how are the runs going? How much churn is going through the system? Does it look like we're fixing the right set of bugs, or is there a lot of churn going through and happening right now? After that, we get into our bugs, seeing what the defects look like and who they're assigned to. Are there any hot teams? Do we need to do any load balancing? And really, from a quality perspective, how severe are the issues? All parts of the trajectory and those sorts of things. And again, the core thing is for developers, look, I'm just checking in my code, right? And the testers are just testing the code, and it's all going into TFS. So they're not doing a lot of extra work as an engineer to give me data. I just get to go pull it. Right? That's one of the core things. But for me, I can look at these views and say, okay, are we on track? Are we headed in the right way? And I can tell you that, so we use this process quite a bit. We use these reports now, and we keep adding more and more of these. Just last Wednesday, I spent about 6 hours straight with all of the teams, and we sat down and went through our entire progress towards the beta milestone of Visual Studio 11, that product, because we're working on that milestone, and we use exactly the same reports. Every team coming in, previews of all this content, and again, live data pulls coming out of the ALM system that we can use to see, okay, how do we feel about it? Are we on track? Do we have any issues? Where are the teams hot? Et cetera. So that's working actually quite well. Now, if we look at the roadmap, we talked about the first two. So what are we doing about Visual Studio 11? And at this point, hopefully, since we're Thursday morning, you've actually already seen some of the material that we have. But I want to make sure, again, level set-wise, we understand where everything's coming from. First of all, we've added 2 more roles. I talked about the kind of bridges, pulling in extra roles, and we did a bunch of stuff. In this, we're adding 2, stakeholders and operations. For these 2 stakeholders, we use the word stakeholder because, frankly, everybody uses a different term for this role. At Microsoft, we use program management. PM is somebody who looks at and does requirements and help us figure out customer issues and kind of how should I design a product and things like that. It's a typical PM kind of role. But a lot of companies call this a business analyst. It's somebody who's directly interfacing with the customer, figuring out what should the features look like when they're done, and we want that to be part of the overall system. So requirements work. Operations, gets us, well, let's just go right into operations and let's take a look at this. One of the things, if we look at operations, again, your code getting built is awesome, but it's got to get out there for somebody to actually use. And so what we do is we want to enable this kind of continuous flow of value, right? So constantly getting releases out here. If I look at this, there's kind of a couple different components to this. First, on the left-hand side, we talk about development. Here, we're using a lot of the common techniques that that we've mentioned here, using Scrum and things like that to be able to kick out the code fast. So groom my backlog, get to the point where I'm using probably a Scrum model, some type of sprint where I can actually go back, build, measure, see how well I'm doing, have a retrospective, know if I'm on track. What's going to come out of that is a working build. Now, just in what we just talked about is all of the things we just kind of did an overview on. Requirements, architecture, implementation, testing, all these things have to be done in order for me to get down to that well-working build at the bottom part of this cycle. Once I get it done, it's going to get off into operations, right? Now, if I'm running a service, that means I'm literally going to stick it into the data center. It's going to come up live, and people are going to start hitting that service through their client software. They're going to start using it. Okay, well, now it's going to have its own sorts of issues. There's going to be the ops backlog. Okay, we're going to have issues. We already know that. Some of those issues you're going to be able to solve directly with your operations team. You're going to find a password reset issue, a router went down, some kind of a hard disk crash, whatever it happens to look like. And our ops teams know how to handle that, and they'll take care of that. But you're also going to run into the issues where it's like, this actually needs to get escalated up to our engineering team. Now, you guys get the bug ping pong problem with dev and test, right? Works on my machine, doesn't work on mine. Well, that's what we were trying to do with actionable feedback. Capture the video, capture the trace log, everything that's required from a tester, it just automatically collects. So when a developer comes back to look at the defect, they can say, I get what's going on. We're trying to do the same thing here with operations, so that when it comes back around the other side, what if instead of getting a pager number for level 2 support, where I got to call them and say, hey, give me a call stack. What's a call stack? You know what I mean? Like that's ping pong. That's not going to work. Well, we want tools that are actually going to collect that data in runtime and be able to funnel that automatically back through. That's actionable feedback. Same concept as the dev test loop or the architect dev loop, but now coming back this way, but from operations. So that's really important. Now that's going to help us with two things. These outer dashed lines that you see here, the first one is cycle time. In the end, what I want to do is I'm trying to get to the point where I can ship as rapidly, but with high quality, as possible. And then there's this mean time to repair that says when I know I have an issue, how long does it take for me to actually get that thing up and running again, right? So if you think about this, just think for yourself just a moment. I've got software, source codes and assets are over here, and I've got it deployed for customers and they're using it. Okay, now, let's say we wanted to do a null build, okay? I don't want you to add any features. All I want you to do is take your assets, all your source code, however you build your product. Just go take that and respin it and get it back out to your customers. How long did that take you? Right? How long is that cycle time? And how many people were involved? How many transitions were involved with that? Right? Take a look at that for a moment. Just think about that. And now you start asking yourself, okay, is that good? You pick your number in your head. I can tell you that for previous versions of VS, for us to do that same thing, I gave you a very long example where my cycle time of making a change and getting it through the original system could literally take me 3 or 4 weeks just to get back to a working build, and then we would start testing, and I get out to 6. No good. Right? We're down to the point where we can actually, for VS, I can basically take those millions of lines of source code and get builds done every night and get the builds up onto the share with automatic testing, a bunch of the product stuff that you've already seen. I can basically do the basics of that overnight. Now, it's still not ready for you guys, so I got more work to do there. But when I start thinking about a service, which we are now running, I'll talk about hosted TFS in a moment, but I've got a service now that's running. You're connected to it. You expect it to be up all the time. So I think if you look at it, in the industry, the best that vendors are able to do with updating his services, we talk about this continuous service, is daily builds. If you look at the folks that are running out of the valley, a lot of the startups, they can actually make changes to their system and deploy publicly on a daily basis. That's where their capabilities are. That's the same capability that we are working to get in our own system so that we have the capability of doing that daily. We're not there yet, but we are working on that. So if, again, you think of all those steps that are involved, you should think back to the strategy and the roadmap that I described. And what we've been doing is systematically looking through every one of those steps and figuring out what would make these two things come together more smoothly, what would reduce the gaps between people, what would get things to not have hiccups along the way so that I could actually make this loop run incredibly fast. Right? So this is where we're going, and this is, if you think about developer operations, this is, kind of the way that we think about pulling these things together. Several features are required for that. On the development side, being able to figure out, well, what features I'm going to add in what order, so getting your backlog right. Also getting the requirements, piece lined up, and I'll show you a couple of these. And then also, as we mentioned, the quickly, triaging incidences on the other side. You have to get all of these in here. So if you look at our feature set for Visual Studio 11, picture this picture right here, and where would those features land on this, because we're all about trying to make this loop run incredibly efficiently. Now, I've talked also, I should mention, I talked a lot about Scrum and Agile and that sort of thing. I do want to make sure I point out that that is one thing that we've invested in to make sure that's easy, because we see a lot of customers that like that, but that's not the requirement for using the system. We still pull the data out of your templates. If you've got customized project templates, data coming through, if you're using CMMI, whatever you happen to be doing, we still make all of that stuff work. We just happen to want to produce out of the box a very good Agile system. So just throw that out there so I don't avoid confusion. So a few different things that we've done. First of all, we did lightweight requirements. This is not to be confused with architecture, obviously, but this is requirements. And the thing we've usually seen is how many times have you built exactly what somebody asked for, but not what they wanted, right? And we see that problem all the time. You get requirements, you spend 4 months, you build the product, and then you come back and say, well, that's not what I want. It's like, well, how do I make that lighter weight? And so we actually built this support here with the PowerPoint team. We worked with PowerPoint, got a few extra kind of ways to get in here. And this pane on the right is storyboarding for PowerPoint. And the cool thing about that is, here's a phone application. I can just drag and drop everything onto this, and it's PowerPoint, which means that I can actually send a PowerPoint file to my customer and have them go click it. And because PowerPoint itself has nice animations, it also has hot links. I can put a button on there. I can actually hook it up so when you push the button, it navigates to a new slide, which is supposed to look like a new screen. And so it's all about how can I quickly iterate. Here's how the app will basically work. Do you like it? But again, it's PowerPoint, so you don't confuse it with working software, because that's a problem sometimes where you built it, it's almost too realistic, and then your customer comes back and says, oh, great, you can have this next week then, huh? It looks pretty good. It's like, it's PowerPoint. It's documentation, trying to get your feedback on it. So that's step number one, a lightweight. Once I do start getting the product in place, you'll probably recognize that view on the left-hand side of the screen. This is some of our testing support. We've actually pulled in the same support, but now for feedback. And so as you go through, you can give it to your analyst, whoever is actually required of that. They can go in and try the new features and start giving you live feedback in the middle of the cycle. So rather than waiting a really long time and then saying, hey, here it is, it's finished, do you like it? Shoot, let's all back up to the start and redo it again. I can actually be giving them more regular builds, and with the feedback tool, just like with your test team, they can actually, I can watch a video, they can put in comments, I can turn around and promote these things into issues that I'm going to track and go put on the backlog for the team. So now I get that nice kind of feedback loop. Once again, removing a gap between two people, involved in building software. After that, Scrum, we've added a bunch of support in here for doing backlogs and being able to figure out capacity, how much time is left, and being able to schedule these on a regular basis, in addition to doing task boards. Again, all hooked up through TFS, and so I can basically implement, I can do the daily stand-ups. If you walk around my building in Building 41, we're getting to the point where everybody is starting to use all the support, because I mentioned the dog fooding thing. Basically, when we get, these are new features for this release, the way that works is the ALM teams build them, they start using them. So a few hundred people on a server start using it. Once it looks good, we promote it back for everybody else to start using, and then we start using it, and then you see the build, and you can go use it. And so throughout this product cycle, that's the evolution we've been making. Is you started, what you'd have is a whole bunch of places in Building 41 where right about here are dirty walls. You guys have dirty walls down your hallways with Post-it notes behind you? With a Scrum? Everybody's, hey, daily stand-up. So you kind of go off and go do this. So we've moved from the Post-it notes to getting more into like, hey, let's actually go grab the monitor, and we're all standing around and using that because it's live updated, and we can actually see where the results are. So once again, trying to get that content in there. After that, the operations side, we actually showed this at Tech Ed North America, but we have a plugin for System Center. That's one of our first plugins, and it won't be the only one in this space. But the plugin basically allows your operations professional to go in and these problems you see at the bottom, using some of the Avocode technology, we actually capture call stacks, which means if the person, the ops professional, if they right-click and say promote to escalation or escalate to engineering, whatever the term is in the menu, then we actually have a bridge back to TFS. And it'll record all the ops issue, stick it into a TFS queue, and now as an engineer I can start seeing, hey, is my system up? What's the problem? I start getting more of that diagnosis data coming back much more quickly. Okay, wrapping this all back into our own stuff. And I know Brian Harry talked earlier this week about some of our hosted TFS, Team Foundation Service, and our lessons learned on moving into the cloud. Well, I want to apply everything we just talked about to our own team now. A few different things. One, we're on premise today. You guys get this more than anybody else because I'm sure you're evaluating using already. But TFS itself as an example, Windows Server, SQL Server, SharePoint, Office. I mean, all these components. That's what the technology is. It's a ton of C#, a ton of SQL stored procedures, a ton of those sort of things, and then again with the client code kind of wrapped around it. Okay, that's great. But when we move over to the cloud, now we start making a different architecture. We've got an architecture now that also supports blob storage for some of your bigger file contents, SQL Azure for the relational sort of pieces, multiple worker and web roles that are associated with that, plus the federated identity system. I mean, this is the system that we've built. And so as we go through and build this, I need to get to the point where, once again, I'd like the capability to ship this thing daily. Right? And we're getting closer. We're getting very close. And all of the changes and improvements that we're making are designed to get us down to that. Now, I'm not literally saying that once a day we're going to go off and go ship a big brand new version of the TFS schema. No, I'm not saying that. What I am saying is, if you think about it, I may have an operational issue that I need to patch. I need to be able to do that on a daily basis. I don't, that needs to feel like something that's the norm, as opposed to, oh shoot, the server went down. Let's all go scramble code red. I mean, you want more of that capability when you're online, which is different than on-premise software. It's a little different if I stick it on a DVD and I hand it out to millions of people. But if you're operating a service, that's kind of where you want to get. But the principles and the sort of things you're trying to enable, I think, are applicable, generally across the board. So that's where we're moving. I'll wrap up with implementing some changes here. So what has all of this kind of stuff meant for us? I mentioned a few things we changed along the way for planning purposes and how we've adopted some of the same practices I think you are, and how we're trying to incorporate that back into the product. Also, as we transform ourselves as a company into doing much more cloud and services work, then we wind up seeing a whole bunch of additional changes. So talk about engineering practices, enabling this rapid turnaround and those sorts of things. That really does require you rethink how you do some of your planning if that's the programming that you're trying to enable. So I mentioned before this kind of waterfall and Scrum combination. I do waterfall planning at my level because you see the public releases that come out. I need to get a lot of people and a lot of code in a product that all works 100%, and I got to pick some dates for that kind of makes sense. And I think many of you have similar issues. If you're building a product line or if you're bidding on contracts, it doesn't really matter. But we have some level of, certainty we need to provide. Now, but within that, I can actually have my teams do Agile, and they can actually be using that system because they're actually getting and going faster. And I've absolutely seen that. SFE as well as Scrum. Two big examples I'll just pick from our own stuff. Engineering practice changes for this release. We're actually shipping higher quality. Our metrics, if I compare them, release to release, are actually significantly better this time around. In fact, I'm going to, implement even a few more for the next version because I like what we're seeing. After that, roles and interactions start to change. I mentioned developer operations. Well, the one thing that was weird about that chart is, you notice I had a big line right down the middle of it. And it is kind of how we operate today, right? We build a bunch of engineering stuff, and there's the ops team over here, and it winds up being a big gulf. What we're starting to see is that the more and more you're operating a service, your engineering team actually has to get more involved with that. Nothing made us appreciate and do a better job on things like SQL Server as a product than when we started running it as our own service and started seeing all the places where, shoot, if that problem happens, I sure would love this data. And so you're starting to see some of that with SQL Server 2012 and some of the new Azure work that we're doing. We're finding some of the same thing with TFS itself. As we turn it into a service and operate it, you expect to see more and more of that. But when you want to keep that stuff up and make it live, you have to start actually getting your engineering team involved in that kind of operating the software and making sure that it's running really well. What that leads to also is your team, and does it have the right makeup? Does it have the right DNA? Because if you are going to get into this kind of mode, you have to sometimes rethink how you're building software. I mentioned a really good example from Microsoft's experience. I've been at Microsoft for 19 years now. I've learned a lot about shipping client software and how to deploy stuff out. I got code in Windows, so I've shipped literally to 1 billion humans on the planet. There's a particular way that you do that. Very, very high quality up front. We roll out the updates for that. If you have an issue, you generally can't go roll back a whole bunch of people. You got to figure out a way to kind of roll things forward, and you got to figure out plans for how you kind of build that stuff up. That is a very particular way of building software, very legitimate and concrete for that kind of environment. You're running a service, it's different. It's up and live every day. I own the bits, and I'm operating them for you. I still have a point at which I release that software out there, the on-premise product and those sorts of things. But when it's out there and live every day, you might get more to a point where you're actually doing fast rollback of changes. And when you do database and schema migrations, you're actually getting more. Today, you might do a schema migration from version 2008 to 2010, and hopefully up to 2000 and mumble whenever we ship the next version. Internally on the service, we may be changing the schema every 6 months. And you should never care. But again, I have to kind of think about how that works. And so the kind of DNA and the way that you do that, plus the operational aspects, I have found that it is changing the way we think about how we engineer our own code. And that is an interesting kind of, it's a little bit of an interesting change in figuring out how to kind of manage that. All right. So with that, let me wrap up. And I know we started a little bit late. Well, how long do we have? Do we have like 5 minutes, or are we?
Well, Jason, I'm not going to pull your plug, but, wrapping it up is good.
Okay. That's the signal for you've talked too long. I think it perfectly filled the hour. It's done. So, all right. Should we take a couple of questions if people have any? Otherwise, we'll get you right onto the.
And I can do that. I can run a mic down to somebody. So if you raise your hand, we can get it.
Okay.
I see one right here in the fellow in the white shirt. So we're going to pass the mic down to him.
So we saw a lot in your deck about metrics, a lot of bugs per person, etc. As a large organization, how are you dealing with things like Campbell's Law, i.e. people gaming those metrics to make the lights go green?
Yes, yeah, and a little bit of the I'm going to write me a minivan tomorrow.
I'm going to write me a minivan, yeah.
Yes, yeah, it's one of my favorite Dilbert cartoons. Yeah, and so generally what we wind up doing is, for me, I'll tell you what I do at my level, because honestly, this all comes down to the engineering leads that actually have the team directly. At my level, I don't actually go in and set the bug rates per person, right? We don't do that because, frankly, the bug rates per person actually, that's a metric that is totally dependent on the team. A developer working on the GC, I expect them to fix 1 or 2 bugs in a week, and no more than that, because it is actually that complicated. However, if you're actually like owning a dialogue where it's kind of fit and finish and pixel issues, I may expect you to do 25, 30 bucks a week. Now, so what we generally do is we go and we say, okay, the engineering lead, the person who actually manages the 5 people that are typing code for this feature, they have to go back and set what that looks like. It's their plan. So we ask them to kind of go drive it from bottoms up. And at that point, if they miss their plan, it's like, well, it was your plan. Tell me what's kind of going on. And we kind of look at the system. Do we get some of that sort of behavior? I'm sure there's the a little bit of that kicks through. But generally, once I ask the team to come up with a plan and they own it, generally we find that we don't see a lot of that. And usually when there's issues, do we have issues? Yes, absolutely. We did have a couple of teams that came back red. I mentioned last week on beta, a couple of them came back red. In some cases, what happened is they tell me if you ever heard this one before, they bit off way more than they could actually get done in the milestone. So they finished up the designs, but now they got a log bug tail. And if you estimate the bug tail to where I want to land, it's not landing. Right? And so, which is fine. It was actually great. The team came in and said, you know what, I'm telling you right now, I can't hit your date. I don't have a plan yet. I'm working on it. We'll meet in 2 weeks. Like, okay, thumbs up. I'm not going to chew your head off for that. I actually rather would hear that. I always tell people, I would rather hear you tell me when it's wrong so I can help you than to find out after the fact when there's nothing I can do now, but cut your stuff. I mean, that's kind of unfortunate. So that's generally the way it's worked. I see a couple of hands up there.
All right, who gets the next question?
A couple of folks back there.
Okay. I will run all the way away.
That can be loud.
Yeah.
You showed some great charts on those metrics for the exit criteria, when the criteria were and where they stood, and those overall scorecard. Is there anything in 2011 or in 11 quote
I will say yes and no, and what I mean by that is yes, all the data is in there. It's inside of the cube. What we haven't done, I'm sorry to say, is we haven't taken those particular charts and put them in the box yet. It is something I would like to do. What we did in 2010, as you probably have already seen, we invested in the SharePoint integration and Excel services and getting the cube and all the data lined up. So you can create the custom reports that go through. What you were seeing is a combination of a little bit of customization on the templates themselves for the extra exit criteria that we have, and then having the teams go in as they go through and do the checkpoints, updating those. Now we can pull the data back up through the cube and go do that. I certainly would be interested in hearing if you saw ones in there that you felt were like really super interesting. We're always kind of looking for examples of that. So do feel free to send me, Sam Mail, Sam GU, Jason Z. Let us know which ones you thought were the most interesting. We'll figure out how we can kind of incorporate them in there. Because I do think the data is there. Like I said, there's other ones I'd like to add. I'd like to add more of the perf stuff that you saw. We've invested heavily in that, especially in the 11 product. I would love to get more of that wrapped around the profiler with the gated check-in stuff. There's some more stuff like that I'd love to do too.
I can say thank you very much, Jason.
Okay. Thanks a lot, guys.